Okay, so today we are going to do practice test for test 3. There are 39 questions as you can see, but I am only going to do non-repeated questions, okay? And these are the questions from unit 7, 8 and 9. So first question, write a set of order pairs x comma y. So as you can see here, the first column is x, which is the name of the city, and then second column is y, which is elevation of airport of that city. Okay, we just have to make a set of these order pairs. So Springfield comma 5, Denver comma 5883, Augusta comma 5, San Francisco comma 11. So that's how you write down set. So here if you click, you are going to see one of the option is x coordinate should be name of the city, y coordinate should be the height of the airport for that particular city. So this is the right answer. Okay, so what's the second question? The domain of the relation. Domain means always the x value. So all these names, that's the domain. So Springfield, Denver, Augusta, San Francisco, that's the domain. The range, it's all the y values. So here in this case 5, 5883, 5 and 11, but you don't have to write down the 5 twice. Okay, 5, 5883 and comma 11, 5, 5883 and 11. You don't have to repeat this 5. The relation is a function. Is it a function? So whenever you see for every single input there is only one output, then that's called function. So meaning for one x value, if there is only one y value, that's called function. For Springfield, the value is 5. For Denver, so all of these city, they have one unique value. So that's why it's a function. So it is a function. The relation is a function. So that's question number 1. Question number 2, you just have to use this this graph and find out the x coordinate and y coordinate for each of these points. So for the first point, x coordinate is -4, the y coordinate is 3. The second one, it's a -1 and +1. The third one, which is 2, there are 2 points, 2 comma -1 and 2 comma -4. And the last one is 3 comma 3. So x and y coordinate, you always have to choose this one, and then after that you have to choose like this. So x coordinate for the first point is -4, and then y coordinate is +3. The second point, you always have to give the comma, and x coordinate is -1 and y coordinate is +1. Third point, and then there are 4 points. I'm going to just use this parenthesis, fifth point. So how many points are there? 1, 2, 3, 4, 5. I'm going to write down the coordinate for the third point, which is 2 comma -1, which is this point I'm talking about. And again, for the same x value, there is a y value -4. So, and finally the last one is 3 comma +3. So this is the the set of order pair. Make sure to use comma to separate the multiple order pair. So make sure that you have to use the comma. I missed that one. So here is the comma, here is the comma, and here is the comma we need to use. And that's the right one. The domain is all the x value coming from this relation. So use this set notation and collect all the x value, which is -4, -1, +2. +2 is repeated, but you don't have to repeat in the domain. Okay. The range of the relation, range means all the y value, which is +3, +1, -1, -4 and +3. So +3 is repeated, so you don't have to repeat that. Finally, is this a function? Look at here, for the input 2, there are 2 output, -1 and -4. It's not unique. So for same x value, if there are 2 y values, that's not a function. so it is not a function. Okay, so that's question number 2. Let's go to question number 3. Here we need to find out either this graph represents a function or not. We can use the vertical line test. By using the vertical line test, we can see that any vertical line, even the y-axis, is crossing at 2 different points, so it's not a function. Here you can see it's not a function because a vertical line, you can draw a vertical line which will cross this graph more than 1 point. Even here it's very easy for this one because the y-axis is a vertical line and it's crossing more than 1 point, so it's not a function. Here if you draw through these points, as you can see that there are 3 points on the same vertical line, so it's not a function. Here for each point, if you draw a vertical line, so there will be no 2 points on the same vertical line. Okay, that's why it's a function. Same goes to here, it's a function because there will be no vertical line you can draw which crosses the 2 points on this graph. Okay, let's go to next question. So next question is we need to find out either this equation represent a function or not, y as a function of x. So only one thing you have to keep in mind is y doesn't have even power. So for the first equation, as you can see, look at the power of y. Look at the power of y. Y has power nothing, that means 1, so it's a function. In this case, the y has power 2, which is even number, so it's not a function. Here y has a power 1, so it's a function. Here y has a power 2, so it's not a function. Since we are looking either y as a function of x or not, we have to focus on power of y. And if power of y is even number, then that's not a function. If it's a odd number like 1 here, then it is a function. Let's go to next problem. Problem number 5. The function f and g are defined. Find out the value of the function at -2. Just put x equal -2 here and do the math. Where is that? So x equal -2 for the first function, as you can see here, f of -2. Just replace here wherever you see x by -2 and just do the calculation. 2 times -2 to the power 3 is -2 times -2 times -2, which is eventually -8 plus 6. 8 times -2 is -16 plus 6. And if you add this, because there is a negative sign and there is a positive sign, you have to subtract. And finally, the answer is -10 for f of -2. You can do the same thing for z. 4, just replace that x by 4 and do the calculation. 4 times 4 is 16 plus 4 is 20. So the answer are -10 and +20. What happened? Did I do something wrong? 4 times 4 is negative. Okay, I did something wrong here. I missed the negative sign. Do you see that negative sign here in front of this? I missed that negative sign. So 4 times 4 is -16 plus -16 plus 4 is -12 actually. So you have to go here and fix it. -12. Make sure that if you are taking a test, you will not be able to fix it. So you have to double check your answer. Okay. Next problem. Domain of this type of function can be found by looking at the denominator. Look at the denominator and then factor those denominators. So let's start with function f of x. So there is a x minus 9 on the top and there is a x square minus 7x minus 18. So this x square minus 7x minus 18, you can factor this by using AC method. So you need the two number whose product is -18 and whose sum is -7, and those two numbers are -9 and +2. So -9 times +2 gives you -18. -9 plus 2 gives you -7. So these are the two factors you are going to find for the denominator for the first function. So now whenever you try to find the domain, what you do is you try to see what value of x make this denominator 0 by equating this each of these each of these factor equal to 0 and solve for x. So when you solve for x here, x minus 9 equals 0. If you just add 9, that gives you x equal 9. And here if you just subtract negative 2, it gives you x equal negative 2. The meaning is, if x is 9 and x is negative 2, this denominator becomes 0, which we don't want. So the domain of the function is all the real number, all the values for x except 9 and negative 2. So how do you write it? Using the interval notation and union notation. So you go to the real number system, which is from negative infinity to positive infinity. From this real number system, you don't want negative 2 in the domain and you don't want positive 9 in the domain. So how do you write it? You start from extreme left, which is negative infinity. You go up to negative 2, but you do not include negative 2 because at negative 2 the function would be 0. So you just use the open parenthesis, and you just start right after negative 2 by using this parenthesis again. This parenthesis negative 2 means you just start any number which comes right after negative 2, comma, you go right before positive 9. So that's the reason we are using parenthesis. And then you go anything after 9 and you go up to positive infinity. The meaning of these intervals are, hey, I'm good to pick anything for x except negative 2 and positive 9. But using the interval notation, you also have to use union sign. Union means this interval, and this interval. That's how you write using the union sign. Okay, so that's what we are asked to use here. Write each answer as an interval or union of intervals. So how do you write it? You use three different interval. I'm going to use those three different interval. You start from negative infinity, you go up to negative 2. Let me double check here. It's negative 2. Yes, negative 2. And then from negative 2 to positive 9, and from positive 9 to positive infinity. And that's your domain for the first function. You can do the very same thing for the second function. You can find out the factors of this x squared plus 14x plus 49, which is if I use the same idea here, these are the factors for x squared plus 14x plus 49. I need two numbers whose product is 49 and whose sum is 14, that is 7 times 7. That gives you the two number. So x plus 7 times x plus 7 gives you this factor on the denominator. That means both of them are the same thing, so we just have to solve this one. For what value of x plus 7 becomes 0. If you solve this equation, that gives you x equal negative 7. So the domain of g of x is any real number except negative 7. So if you draw your number line, which is anything from negative infinity to positive infinity, somewhere here you have negative 7. So your domain is everything from extreme negative infinity up to positive infinity except negative 7. So how do you write that thing? Using the interval notation. You start at negative infinity, you go right before negative 7, union sign, you start right after negative 7 and you go up to positive infinity. So you need two interval starting from negative infinity up to negative 7, and then right after negative 7 up to positive infinity. Okay, let's go to the next question. Question number 7. Okay, this is exactly the same. To find out the domain, you have to repeat whatever I did for these two questions, and there are three problems you have given. You exactly find the same thing. For the first question, the domain is all real number because there is no denominator and there is no radical sign. So function like this, which is actually quadratic function, the domain is all real number, meaning you go from negative infinity up to positive infinity. And then for the rest of the problem, you need to find out the factors. If you find the factors of x squared minus 4x minus 12, you are going to get x minus 4 times x plus 3. No, no, I need two number whose product is negative 12 and sum is negative 6. So that means the factors of x squared minus 4x minus 12 are x minus 6 and x plus 2, because negative 6 times 2 is negative 12, negative 6 plus 2 is negative 4. So 6 and negative 2 are the two number which is not part of the domain, by using the same fact we did for previous problem. So the domain is all real number except 6 and negative 2. So how do you write it? The way we wrote for problem number 6, exactly the same way we can write it here. So the domain is all real number except positive 6 and negative 2. So you start from negative infinity up to negative 2. Look at here, negative 2 from here, and you go from negative 2 to okay 1 2. First one is no first one is negative infinity to negative 2. The second one is what is that, negative 2 to positive 6. It's coming from the second part. And third one is what is that, positive 6 to positive infinity. And then finally for this one, domain is all real number except negative 1. So that means you need two interval, which is what is that, negative infinity to negative 1, and then another one is negative 1 to positive infinity. So these are the two intervals you need. What happened? Did I do something wrong? Here I use the positive the bracket sign. It's not the bracket sign, it's supposed to be parenthesis. So that is the mistake I did. It's supposed to be the parenthesis. Okay, so what is that? I need to make it parenthesis. So now recheck it. Now it's all good. Okay, so whenever you have to find out the domain, you just if you have the fractions, you have to make your denominator non-zero. Okay, so let's go to the next question, and next question is problem number 8. As you can see here, it's a radical sign. For finding the domain of the function like this with the radical sign, you want to make things inside the radical sign non-zero, non-negative. Meaning, so in this problem, as you can see, there is a radical sign and there is this thing, negative x plus 2. To find the domain, you copy that thing under that radical sign and make it greater or equal to 0, and you solve this inequality. That gives you the domain. When you try to solve this inequality, if you add x both sides, that means 2 is greater or equal to x. Another way of saying the same thing is x is less or equal to. So if you write down this thing in the interval notation, there is a 2 and your domain is anything less than 2, including 2. So you start from negative infinity and you go up to 2. So how do you write using the interval notation? You use the parenthesis, negative infinity comma positive 2, because you are including 2, so you have to use the bracket. So on the left side there is a parenthesis, on the right side there is a bracket. So that's how you find domain of this function with the radical sign. Okay, what's the value of this function when you replace x by q minus 3? Just replace this x by q minus 3. So as you can see here, k of x is x squared plus 3 times x. Replace this x by q minus 3. Wherever you see x, just replace that by this expression, whatever comes inside this parenthesis. So 3 times q minus 3. You have to replace this x by q minus 3 for this function k. Okay, so as you can see here, they are saying simplify your answer. So you are not done. You have to use the square of q minus 3. You have to distribute this 3. So let's see what happens. If you take this q minus 3 square, which is q minus 3 times q minus 3, that will give you q square minus 6q plus 9. And if you distribute this 3 here, that will give you 3 cube minus 9. So this 9 and this 9 will be cancelled out because one is negative, one is positive. And now it gives you q squared minus 6q plus 3q. So if you combine these two, one is negative, one is positive, you have to subtract from bigger one to small one, and that will eventually give you negative 3q. So that is your final answer, which is q squared minus 3 cube. All right, let's go to the next problem. Problem number 10. This is called difference quotient. You have to calculate this difference quotient using the function given here. First of all, calculate the value of the function when x is replaced by x plus 6 by doing exactly we did for this question here, question number 9. So if you replace this x by x plus h here, that will give you 2 times x plus h. So if you replace this, here is the function and here is the x, 2 times x minus 9. You want to use x equal x plus h, which is 2 times x plus h. If you replace this x by something on the left side, you have to do the same thing on the right side. So if you just distribute this 2, that will give you 2x plus 2h minus 9. So eventually this is the expression for fx plus h. So that's the answer for the first part, which is 2x plus 2h minus 9. Now for the second part, you take this thing on the first part minus this thing on the second part, and you do the simplification. So the f of x plus h is this one. So fx plus h minus f of x over h. That's what you want to find. Fx plus h is 2x plus 2h minus 9 minus f of x is, if there is a minus, you have to use the parenthesis because you have to be you have to change the sign because of this minus, and there is a h. So if you distribute this minus here, that will be 2x plus 2h minus 9, negative 2x, negative times negative is positive 9 over h. This positive 9 and this negative 9 will be cancelled out. Eventually this negative 2x and this positive 2x is also cancelled out. There is a 2h on the top, there is a h on the bottom. Because there is a multiplication sign between the terms on the top, you can cancel one of the h, and eventually the leftover would be just 2. That looks right. So let's go to next problem, which is problem number 11. So problem number 11 is again very similar question, so I'm going to skip it. This is very similar to problem number 10, so I'm going to skip problem 11 and go to the next problem, which is problem 12. Use the graph of y equal f of x to answer the following. You have given the graph. Find out the value of the function when x is negative 2. Function means the y value. So to answer this type of question, go to the x-axis at negative 2, and at that point find out the point on the curve, which is basically this one, and find out the value of y on that point. So here you can see that the graph is touching x-axis, so the y value is 0. This is actually the y value for that point. The value of the function means it's the y value. What is the y value of the function on this graph when x value is 4? So x value is 4, that means here the y value can be found by going here, which is 2. So that's 2. What is the find all x for which the function is negative 1. So go back here, find out the curve where the curve is negative 1. So negative 1 means here, look at here. At this point the value of the curve, the graph is negative 2 and the value of x is 2. But if you go back to the left side, you can see that there are 2 points where the x equal y equal negative 1, this negative 1 line crosses 2 more points. So focus on if you draw horizontal line through this -1, how many places that horizontal line is going to intersect with this graph? This point, which is x equal -3, this point, which is x equal -1, and this point, which is x equal to +2. So these are the 3 points where the function is -1. So x equal -3, x equal -1, and x equal +2. So if there is more than one, separate them with a comma. So -3, -1, I'm sure it's -1, yes, and then +2. These are the 3 value of x where the function value is -1. Okay, find out the value of x where the function value is -4. Do the same thing. -4 means draw a line through a horizontal line through -4, and as you can see that horizontal line will cross this graph at this point, which is x equal -4, and at this point, which is x equal 0. They are just asking you the value of x for which the value of y is -4. Okay, determine the x-intercept. X-intercept means wherever this graph crosses the x-axis, they are called x-intercept, like here at -2, like here at +2.5. You see that? So the x-intercepts, there are 2 x-intercepts. And what are they? The x-intercepts are -2 at x equal -2 and at x equal to 2.5. But keep in mind, when you write down the x-intercept, you also have to include the y coordinate, which is 0. Y coordinate for the x-intercept would be always 0. So these are the 2 points where graph crosses. Okay, what happens? 2.5. Let me just go back and check. Is this 2.5? It looks a little bit more than 2.5. So let's say it's a 2 point. Okay, it's if I divide it into equal pieces, it's a 2.5, 2.6. So it looks like it's a 2.6. 2.6. Enter the x-intercept in ascending order and approximate to 1 decimal place. Okay, that's right. That's just approximation. Okay, what are the y-intercept? Y-intercept means where this graph crosses the y-axis. As you can see that it's at -4. So for the y-intercept, the value of x is 0, the value of y is -4. What's the domain? Domain means when you look at this graph from left side to the right side, from where this graph starts on the x-axis, that's where you start. So this graph starts at -4 and goes to the right side, and there is an arrow on the graph, meaning there is no stop. So you start at -4, you including -4, and you go up to +infinity. So that's the domain. So you start at -4, including -4, and you keep going to the right side, and there is no stop. That's why there is a +infinity. The range means the value of this curve on the y-axis. So when you go from bottom to top, where does this graph start? It starts at -4, and then you keep going up, and then here you can see that this graph just goes like this, so there is nothing goes up. So this graph stops here at +2. So the range is starting from -4, it goes up to +2. So the range is starting from -2 and then -4, it goes up to +2. So -4 up to +2. Okay, that's long question number 12. And now, after doing question number 12, after finding domain and range for this question, you can also find domain and range for this graph. It's not big deal. For finding the domain, always look at the graph where it starts on the x-axis and where it ends on x-axis. So this graph starts at -2, including -2 because of this dark circle here. So that means including -2, and then it goes up to +3. Because of this open circle, you are not including +3. The range is, you walk on the y-axis, it starts at -4, Because of this open circle, you do not include negative 4, and then you go up to positive 5. So where is that? This one, negative 4 to positive 5. Okay. Find out the difference between this function multiplication and addition. Difference means just subtract f from g. So that will eventually give you, if simplification is possible, then do the simplification. If simplification is not possible, then just plug the value. So as you can see here, this means g of x minus f of x. X square is the value of g of x minus 4x cube is the value of f of x. Now multiplication, multiply these two. 4 times x cube times x square. If you multiply x cube and x square, you have to add the exponent. Eventually it gives you 4 times x to the power 5, because if you multiply this 4 times x cube times x square, the multiplication between these two means you are adding the exponent. So eventually it's 4 times x to the power 5. Now here add these two functions and replace x by 2. So if you add these two functions, you can do that before, you can plug x equal to 2 here before or after, it's up to you. So first of all, if you add these two functions, it will give you 4x cubed plus x square. Now you want to replace that x by 2, so it will be 4 times 2 to the power cube plus 2 to the power square, which is eventually 36. Okay, it's a division instead of multiplication or addition. Division means put the value of q of x on the top, put the value of r of x on the bottom, if you can simplify them, but there is nothing you can do this time because it's 4 minus x on the top, and then for the r of x it's 2x. You don't have to put negative sign on the bottom part, you can put that negative sign on the top as well, that's the same thing, but the way we always write is negative on the top. The domain of q over r. Keep in mind, the domain means you have to make sure that the denominator is not 0, and you also have to make sure that if there is a radical sign with an even index, then things inside that radical sign should be non-negative. So there are two restrictions you have to keep in mind. The first one, x cannot be equal to 0 because there is a x. So x cannot be equal to 0, that's the first restriction coming from the denominator. And second restriction is 4 minus x has to be greater or equal to 0. If you try to solve this, 4 has to be greater or equal to x, meaning x should be less or equal to 4. So there are two things you have to keep in mind. The domain of this function is anything less than 4, but also not 0. Also 0 is here, not 0. So you want to keep anything else to the left side except 0. So how do you write it? You start from negative infinity, you go up to 0, you use the open parenthesis, union, you start from 0, you go up to positive 4 and use the bracket. That's how you find the domain. So how do you write it? I am going to use this one. So you start from, what is that? Negative infinity to 0. So negative infinity to 0, and then second part is, what is that? I need a bracket on the, okay, 0 to positive 4. Positive 4. Okay, let's go to next problem. This is also very similar. I'm not going to do it, I'm going to skip it. It's a very similar to the previous problem. Problem number 16. Let's go to problem number 17, which is finding the value of the function when you replace x by negative x. Okay, so the next problem, as you can see here, find the value of this function, replace x by negative x. If you do that here in this function, as you can see, if you replace this x by negative x, negative 8x cubed plus 9x, the meaning is just replace this x by negative x. Wherever you see x, just replace that by negative x, on the left side and right side and do the calculation. Negative 8 times cube of negative is negative, so it's a negative x cube. Negative times positive is negative 9x. So this negative and this negative becomes positive 8x cube minus 9x. So that's the positive 8x cube minus, where is that, minus 9x. Check. Good. What is the negative of h of x? Look at here, this h of x, just multiply each of them by negative. This negative and this negative becomes positive. This positive and this negative becomes negative. What I'm trying to say is, if you just multiply h of x by negative, there is h of x which is 8x cubed plus 9x, and if you just multiply this negative and negative, it gives you positive 8x cubed. This negative and positive, that makes it negative 9x. So it's the same thing, 8x cubed minus 9x. Okay, these two values are equal. Yes, they are equal. And if they are equal, the function is called even function. If h of h of negative x equal negative h of x, the function is called even function. Check the definition. Sorry, it's called odd function. Okay, check the definition of the even and odd function. Sorry, that's my bad. If the function, there is a definition. The definition is, if f of negative x equal negative of f of x, the function is called odd function. Okay, let me just okay, so look at here. If f of negative x equal negative of f of x, this is odd function. And if f of negative x equal positive of f of x, that's the even function. So that's the proper definition. So based on that definition, it should be odd function. Okay, next question. Now, by using the same idea, just find out f of negative x and f of negative of x and equate them. If it's equal of negative of f of x, that's the odd function. If it's equal to the positive of f of x, it's an even function. If this is not equal to first one or second one, that's the neither function. So by using this very same strategy, we can find out which one is even and which one is odd, but you have to do it manually. So I'm going to leave you do this, and finally you can find out which function is even and which function is odd. You have to use this definition. Okay, the way I did, you have to find out this thing. Okay, I'm going to skip it. Let's go to the next problem, problem 19. You have to graph a linear function, which is a straight line. As you can see that this graph has okay, just give me a second here. Okay, so we are looking at problem 19. As you can see here, this is a y equal mx plus b form. So g of x equal negative 3x plus 2, where 2 is your y-intercept, negative 3 is your slope. So y-intercept means 0, 2 would be on the graph. So 0, 2 means 0, 1, 2. So this is a point on the graph, and because of this slope, which is to find the next point, we can go from here 3 unit up, 1, 2, 3, and then because it's negative, go to the left side. Okay, 1 unit left side. So that will help us to find another point, which is eventually 5, negative 1. Sorry, my bad. It's a negative 1, 5, and that's by just joining these 2 points, we're going to find the graph. So starting with 2, okay, my bad. It should be negative 2. Okay, here is the negative 2. There is a negative 2 instead of positive 2. So your y-intercept is 0, negative 2. So 0, negative 2, 0, negative 2, negative 2 for that point, and another point is 3 unit up, 1, 2, 3, and 1 unit to the left, which is negative 1, and then 1, 2, 3. So that means it's a positive 1. plot that, and now just use this line through these 2 points, and then you are all good. Okay, that's how you can plot the graph for a linear equation. Now this is a transformation. The graph of y equal f of x is given here. Translate it to get the graph of y equal f of x plus 5. If you are adding, that means you are vertical shifting 5 unit to the up. So translation, 5 unit to the up. So from here, which is starting at -1, 5 unit up means it goes up to +4. Make sense? Here in this case it's x minus 3, so it's a horizontal translation to the right. Because there is a minus, so you go 3 unit to the right. 1, 2, 3. Translation 1, 2, 3. And then you are going to get that translation. Okay. Okay, so let's look at number 21. Below is the graph of y equal x square. Translate it to make it graph of y equal x minus 5 square minus 3. So here this is the combination of two different transformation. X minus 5 whole square, it is actually it's a horizontal shift to the right, and minus 3 it's a vertical shift to the down. So whenever you have horizontal shift and vertical shift, they come together, you always do the horizontal shift. So you take 5 unit to the right, so this is 5, and 2 unit to the down, 3 unit to the down, there is a -3. So that is your transformation. Okay, you have given function y equal f of x, the graph of that function, and you want to draw graph of y equal negative f of x, which is a reflection about y equal negative f of x means it's a. So now look at here. So it's a reflection about x-axis. So whatever you have here, so instead of so reflection about the x-axis means whatever y coordinate you have here on the graph, just make it opposite. So as you can see here, it's at 4 the value is -1. So at 4 the value for the reflection would be +1. Okay, so how do you do that? You can just plot the point. Let's say at 4 the reflection of -1 is +1. So here at the end point, you can see at -4 the value of the y coordinate is -3. So at -4 you don't change the x coordinate, you only change the y coordinate because it's a reflection about the x-axis. So the only thing you have to change is y coordinate. So by plotting this end points, now we just have to join these 2 points, and it gives the reflection about the x-axis. In this case, because instead of x there is a -x inside the parentheses, it's a reflection about the y-axis, meaning you keep the y coordinate same, but you just flip the x coordinate. So you start with this point 0, 2. So y coordinate is same, x coordinate instead of 0 you have to make it -0, but -0 is 0, so that's the same point. At 0 the y coordinate is 2, so this point doesn't change. For this point, which is if you look at the point at -2, the value of y is 4, so we just flip it to the other side. So at +2 the value of y would be 4. So at +2, here you can see that I just flipped the x coordinate because it's a reflection about y-axis. And finally, I need this endpoint here at -7, the value of y is -1. So instead of -7 for the x coordinate, we need the +7. So at +7, the value of the y coordinate is -1. So if you plot it, you will see the reflection. You see that? Now we just need to join these endpoints using 2 different straight lines, and now you can see the reflection about the y-axis. Okay, let's go to the next problem. This is the absolute value function, and by adding 4, it means you are shifting the graph 4 unit to the left, and subtracting 3 means you are taking that graph 3 unit down. Whenever horizontal shifting and vertical shifting they come together, you always have to use horizontal shift first. So I'm going to take it 4 unit to the left, 3 unit to the down, and that's all. Okay, find the difference quotient, this one, for the function below. Simplify your answer as much as possible. I guess we already did one of the different quotient problem before, somewhere here. Yes, that's problem, where is that, problem 10, I guess. Yes, we did problem 10. I skipped problem 11. It was also differential difference quotient. So that is the very same idea here, different quotient. So I'm not going to repeat that. Let's go to next problem. You have given a graph. We need to find out the value of x for which the graph, the y coordinate is 3. Check the graph here where the y coordinate is 3. Look at the y equal 3 here. When you draw a line through this y equal 3 horizontal line, that horizontal line will touch this graph at 2 different places. At 0, when x is 0, the y is 3. When x is -3, the y is 3. So there are 2 points where the value of the function is 3, which is at 0 and -3. Here we want to find out the value of the curve, the y coordinate, when x is -1. So go to the x-axis when x is -1, go to the curve here, which is the value of the function. If you zoom in here, when x is -1, the y is +1. Okay, so this is a value of the function, which is actually you are looking for the y coordinate. Okay, finish your work. Where is the next question? I don't see the next question. Do you see the next question? One value of x for which f of x equal 3. Okay, they are just looking for one value of x, so I gave 2 values, so I'm going to just use 0. Okay, that's correct. So remember, they're not asking all the value of x, they're just asking one value, and I gave 2 values. So just read the instruction, graph the equation. This is also transformation. First you have to transform the graph of absolute value of x 4 unit to the left, and then multiply your this is a combination of so many different transformations, so I'm going to do it here. So the basic function, as you can see here, is absolute value of x. From here you go to absolute value of x plus 4. From here you go to 4 times absolute value of x plus 4. From here you flip it, so that means negative of 4 times x plus 4. And from here eventually you subtract negative 4 times x plus 4. I'm going to show you this step by step. Look at here. Let's say this is your original function f of x. So from here to here you are just changing this x coordinate by adding 4 inside here. From here to here you are multiplying the x coordinate by the y coordinate by 4. Okay, and from here to here you are just flipping the y coordinate. You are flipping the y coordinate, so you are just making it negative 4 times fx plus 4. And from here to here you are just subtracting 5 from the y coordinate. So the changes, whatever changes happening here, we have to see that changes in terms of coordinates. Okay, so I'm going to use this. Okay, let's make it from here to here. The only thing changes x coordinate. So to go from here to here you have to subtract 4 from the x coordinate. To go from here to here you have to multiply the 4 you have to multiply the y coordinate by 4. To go from here to here you just have to flip your graph, which is reflection across the y across the x-axis. That means you just have to multiply your y coordinate by negative. From here to here you just shift your graph 5 unit down. That means you have to subtract 5 from your y coordinate. So now if you coordinate wise, if you try to try to see the changes. First of all, xy goes to x minus 4 comma y. Remember, though you see here plus 4, because it's x-axis, you have to subtract from the original x coordinate. So that's why minus 4. From this part to this part, you are multiplying the previous y coordinate by 4. So eventually it gives you x minus 4 comma 4 times y. So when you try to go from this step to this step, you are flipping across the x-axis. So that means you are just changing your y coordinate, just making it negative. And now finally, to go from here to here, you are subtracting 5 from your previous y coordinate. So you are subtracting 5 from previous y coordinate. So subtracting 5. So originally, if you have xy on your graph, xy point on your original graph, absolute value of x, that point becomes x minus 4 comma negative 4 times y minus 5. So I'm going to use some of the points from absolute value of x. So look at here. This is the graph of absolute value of x. And now I'm going to use this formula to see changes coordinate wise. So let's take some of the points from this function, which is at 0 it's a 0, at 1 it's a 1, at negative 1 it's a positive 1. So if you can keep going, like if you want to find out at 2 it's 2, at negative 2 it's 2, but I'm going to just use these 3 points. What happens to these 3 points? 0 0, when x is 0 and y is 0, that point becomes, put x equal to 0 here, and that will give you negative 4, y equal to 0 here, that will give you negative 5. So this 0 0 goes to negative 4 and negative 5 somewhere here. Okay, that points transform to the negative 4 negative 5. That's the meaning of this formula. This 1 1, if you put 1 for the x coordinate and the 1 for the y coordinate here in this formula, 1 minus 4 is negative 3, negative 4 times 1, negative 5 gives you negative 9. So that 1 1 becomes negative 3 negative 9. So negative 3 somewhere here and negative 9 is somewhere here. Okay, negative 3 negative 9. Finally, that negative 1 positive 1 becomes, let's see here, negative 1 positive 1. If you put x equal negative 1, that will give you negative 5, and y equal positive 1, that will give you negative 9. So that negative 1 positive 1 becomes negative 5 positive 3. So eventually the nature of the graph would not change. The way you connect them is similar to the way they are connecting. But look at here, it's shifting 4 unit to the left, and then flipping it, and then taking the 5 unit down. So that is the final graph you would see. How do you plot it here? You have to use those points, negative 4 negative 5, negative 5 9. So I'm going to do that, negative 4 and negative 5. I guess it's a negative 5. Yes, negative 5 positive negative 9, negative 5 negative 9, and another point is negative 3 negative 9, negative 3 negative 9. So now if you just use these lines from here to here, oh no, that's not the right one. If you use this one from here to here, and again another one from the same point to another direction, that will give you final graph. You see that it's a combination of horizontal shift and vertical stretching, reflection, and then finally vertical shift. Okay, you have to apply that step by step. Whenever all of them come together, always apply horizontal shift, stretching, reflection, and then only finally that vertical shift. Okay, so I guess yes, you have given y equals g of x, and you want to find the graph for 1 over 5 times g of x. So remember, this is your vertical shrinking, because you are multiplying the y coordinate of this graph by 1/5. Okay, so you always have to find these special points. If you know what happens to this one, this one, this one, and this one, the rest is you just need a straight line between them. So here if you see, the coordinate for this point is -5 comma 0. So remember, whenever you are multiplying the original function, you are multiplying the y coordinate only. So when you go here, this write down this coordinate for this 4 points, which is -5 comma 0, and then -3 comma, what is that, -5, and then +3, -5, and finally +5, 0. And this 1/5 means you are just multiplying the y coordinate by 1/5. So when you do that here, the -5 for this one, the x coordinate would be the same. X coordinate would not change. The only change you have to see, you would see is on the y coordinate. So you take this y coordinate, multiply it by 1/5. 0 times 1/5 is 0. -5 times 1/5 is -1. -5 times 1/5 is -1. 0 times 1/5 is 0. So now this points becomes -5, 0. What is that? -5, 0. And then another point is -3, -1. -3, -1. And then +3, -1. and +5, 0. So you have to join these points now. And then you would see the transformation. Remember, this is, you are multiplying the y coordinate by 1/5. That means it's a vertical shrinking. That's what's happened here. It's shrinked by 1/5 size. Let's check and go to the next problem. This is also horizontal shift 2 unit to the left, to the right, sorry, and then it's a vertical shift 3 unit to the up. So I will let you do this. It's a very same idea. Horizontal shift 2 unit to the right, and vertical shift 3 unit up. This is start with the cubic function, and then it's a horizontal shift 3 unit to the left. But when you try to plot this graph, you have to follow the instruction. Plot 5 points on the graph of the function as follows. Plot the first point using x values that satisfy cube root of x plus 3 equals 0. Okay, so now you need one point which satisfies this. So how do you do that? This is what you have to do. This is a radical equation, so you have to solve the radical equation. To solve the radical equation, whatever index you see here, take that power both sides. Take cube both sides. You are allowed to do that, same power. That gives you x plus 3 equals 0, x equal -3. So that means when x equal -3, the function value would be 0. So that's the point you are going to plot. X equal -3 and the value of the function is 0. That's the one point. Let's read another one. Plot 2 points to the left and 2 points to the right of the first point. So you want something to the left and you want something to the right. So remember, if x is -3 here, then take something from the left side and then put that value here for finding the points. So for example, if I just say to the left and to the right, don't forget that. So the x value, and then you have to calculate the value of y by using this formula. So there is a -3, and something to the left means it should be something less than -3. So I'm going to pick -4, and then I'm going to pick whatever value I want to pick. So let's say -5. I don't know, either I can put the radical sign. Yes, so then that's fine. So I'm going to put -5. I'm going to put -2, I'm going to put -1. Okay, so when x is negative, I know for x is -3, the value of y is 0. We already found that. When x is -5, put that here. If x is -5, then the value of the y would be cube root of -2, because -5 plus 3 is -2. When x is -4, the value of y is cube root of -1. Okay, when x is -2, the value of y is cube root of 1, which is actually 1. When x is -1, the value is cube root of 2. So these are the points we can use here. When x is -5, the y is cube root of -2. Plot it and do not approximate. For example, write 1/3 and do not 0.33. What did I do that? Well, okay, yes, okay, we plotted that, right? Did I do that? Yes. When x is -4, the value of y is, as you can see here, when x is -4, it's a cube root of -1. So it's a cube root of -1. Okay. When x is -2, the value is +1. When x is finally -1, the value is cube root of +2. Cube root of +2. So these are the 5 points we plotted. Now we just have to choose the graph and then it will take the shape. Okay, this is the graph of quadratic function. Now x plus 1 means it's a shift to the left 1 unit, multiply by 3, which is a vertical stretching, and negative, that means it's a reflection. Okay, so you have to take the graph to the left 1 unit, and then after that you have to multiply it by 3, which is what is that called? Vertical stretching, 3 unit. So this 0 1 becomes 0 3. So because this point, look at here, multiply it by 3 means you are just multiplying the y coordinate by 3. So 1 becomes 3. And then after that, this negative means it's a reflection. So no. Reflection about that x-axis, yes, because it's a -3. So reflection about x-axis. Okay. Okay, for finding the even and odd function, as you can see here, there is we already discussed about even and odd. A function is called even from the graph. Okay, there are the graphs and there are the functions. So this is neither, because to have an even function it should be symmetric with respect to origin, but it's not symmetric. Symmetric means any point on the graph should have equidistant from the origin to other side. This is not the case here. Here this is your odd function, because if you pick any point on the graph, there will be another point to the other side of the origin on the graph, so it's an odd function. This one, if you look at the power, if all of them are cube, it's odd function. If all of them are even, that means it's even function. There is a proper way to check either your function is even or odd. Symmetric. This graph is symmetric means it's a mirror image. It's not x-axis symmetric. It's not y-axis symmetric. It's origin from here. They are equidistant, so it's origin symmetric. This one, none of above, because symmetric means you should have mirror image, but you don't see the mirror image across the x-axis, across the y-axis, and with respect to the origin as well. Here it's symmetric with x-axis, symmetric with y-axis, it's a symmetric with the origin as well, because you can see the mirror image across the x-axis, you can see the mirror image across the y-axis, and if you pick any point on the graph, other side of the origin, you will see a point, equidistant point on the graph as well. Okay. find out the, it's a composition, find out the value of the function. First of all, find out the value of g at 6, which is, if you calculate this, my bad. Okay, if you calculate that function, first of all, you have to calculate g of 6, which is square root of 6 times 6, which is actually 6. And now you want to find out the h of 6, because g of 6 is 6. So h of 6 means, go here, put wherever you see x, put that 6 there. So 6 times 6 is 36 plus 7 is 43. So the answer is 43 here. Okay. It's a composition. The way we did here, you can do the very same thing. H composite of f negative 1. The meaning of this is h, find the value of h at f negative 1. So first of all, you need to find out what is f at negative 1 by using the function given here. Just replace x by negative 1 in the formula here and then do the calculation. It's a negative 1 cube means negative 1. 6 times negative 1 is negative 6. Eventually it's negative 7. So this value you have to find at h negative 7. So h of x is 3 times x plus 8, which is 3 times negative 7 plus 8, which is negative 21 plus 8, which is negative, what is that? 13. So the answer should be negative 13. Okay. Yeah, I'm going to skip this. It's a very same idea, the composition, like previous problem, but instead of number they are using x. Okay. Here, this is a piecewise function. To plot the graph of piecewise function, you have to plot the graph piecewise. Like, you have to start graphing from this interval from -2 to -1. The graph is -3. So meaning the y value is -3. How do you plot y equal -3? This is actually a horizontal line, y equal -3. But you don't want everything. You just want from -2 to -1. So you start from here with the dot like this. You go up to -1 with the open circle and you just stop there, that part. You only choose this portion and then you do the same thing for other portion here. So -3, -2, -1. Instead of -3, next time you do -2. Instead of -2, next time you do -1. So I'm going to show you how to do that. So starting from -2, I'm going to use solid dot at -3. At -2, where is that? -3, yes, here. And then I'm going to use the circle up to -1, which is here. -1, I'm talking about x coordinate, and I'm going to join these 2 points using a straight line. So that's the graph for the first part. We have to do the same thing for the second part, third part, and last part. But for the second part, the value is -2. So when x is -1, you use the solid dot. The value is -2 here. And circle when x is 0. So you just join them using a line like that. When x is from 0 to 1, you start with the solid dot for -1, and then you go up to +1. You join them using the straight line, and finally when x is +1, you use solid dot, and then even for the 2 you use hollow. So you go up to here. The value of the function is 0. 0 means it's on the x-axis. So that's a piecewise function. You just focus on pieces. This is also piecewise function. This time instead of the graph, I guess the last problem is graphing of the piecewise function. I'm going to skip this for you because it's a piecewise function. To the left of -1, you just draw a straight line, y equal -2x plus 1. To the right of -1, you just draw a straight line, y equal 2x plus 1. So it's a pieces. But I'm going to do problem 38, which is find out the value of the function at 0. So first of all, you look at where 0 is. X, any x from -1 to +4, for that the value of the function is x squared plus 2. So if you want to find out the value of the function when x is 0, you go in the middle, you put x equal to 0 here in this formula. That will give you 0 plus 2, which is eventually 2. If you want to calculate the value of the function at -2, you look at where the -2 is. -2 is less than -1, so you use the first formula to calculate the value of the function. So now you put x equal -2 here. -2 times -4 is +8. +8 plus 7 is +15. -1 means you have to use the middle one. So -1 whole square is +1. +1 plus 2 is +3. And then +4 means this one, which is 5. +5 is also 5, because anything more than 4 is always 5. Okay, so that's the practice test for test 3. All the best.